Welcome back, MEFB 2013. We are currently in welding and abrasive processes. So like I had mentioned to you in the last lecture, every welding processes has its own art and own technique. The key word in welding is the use of electrode. What is electrode again? Electrode is melted. Okay, it is an instrument that is used to melt and deposit into the weld surface. Yeah, so electrode plays a very important role during a welding process. Okay, so if you remember during your manufacturing processes class, you did use an electrode. Yeah, and then when the electrode becomes melts and deposits and becomes smaller and smaller and smaller, eventually you see that you need to when it comes very tiny, you will not be able to use the electrode again. So you need to replace your electrode with a new electrode and then continue your welding process. So if you look at it, I mentioned to you in yesterday's class, there is three types of electrode. You have the bare electrode, that means the electrode does not have any coating. You have fluxed electrode, light coated, and heavy coated electrode. So can you tell me first of all, what is the biggest challenge in a welding process? Okay, so if you remember clearly, I told you yesterday our biggest issue during a welding process would be the formation of oxides on the surface of the weld. And what does these oxides do? Oxides is actually the formation of rust, karat. Yeah, so you have, even though you have an excellent weld, okay, if at the end of the day there is formation of oxides, oxides will penetrate deep into your material, create pore structures. What is pore? Ruang kosong. Yeah, it will create holes inside your structure and it will make your material brittle. Okay, so when your material is brittle, your weld would fracture, break, and it will eventually fail. Okay, so the whole idea of this chapter is not how to describe how an arc welding is done or gas welding is done. You've done it during your manufacturing lab. But the whole idea is to introduce you to the different types of protective mechanisms that is being used during a welding process. Okay, so like I mentioned to you, yeah, protective mechanism for a welding can come in two categories. First of all, the type of electrode you use can protect your weld area from oxidation. Number two, the use of external measures such as a gaseous shield, okay, or ceramic cup to protect the weld area from oxidation. So let's look at the first method, the use of electrodes. Okay, so basically the very basic function of electrode is to melt. It forms your weld. Okay, it forms your weld. So when you use the welding technique, your welding gun is going to melt the electrode and deposit it into the weld area. So there's three types of electrode: bare electrode, light coated or flux electrode, and heavy coated electrode. Okay, so if you see your electrode here, yeah, bare electrode, no coating. If it is a light or heavy coated electrode, if you look at the structure over here, yeah, if you look at the structure over here, this is your electrode, and the black outer surface here is your shield. It may be a heavy coating or a light coating, does not matter, because the coating constituents have substances to protect your weld area from oxidation. So the moment the electrode is melted and deposited into the weld area, the protective mechanism or the shield will form a gas surrounding your weld area. What is the function of this gas? It's actually a protective mechanism. It will protect the weld area during the welding process, because this gaseous shield will penetrate oxygen from coming into the weld area. And if there is existing oxygen or impurities present in the weld area, this so-called coating, whether it be it a heavy coating or a light coating, yeah, whether it's a flux or a contact electrode, does not matter, because at the end of the day, the coating constituents has characteristics to neutralize the impurities, and it will form a slag at the end of the day. Whether it's oxides or any impurities, will form a thin layer of slag on the surface of your weld. So if you remember clearly now when we were doing our manufacturing processes lab, during the arc welding process, if you remember clearly, once you have completed welding, what was the first thing that you did? Okay, you switched off your power, and then you found that your welding surface was in a blackish contour, right? So what did you do? You took a hammer. If you remember, if you took a hammer and you hit on the surface of your, you knock on the surface of your weld, and when you knocked, the black substances cracked, came off, and you could, beneath it, you could see a shiny weld. Okay, so that is your actual weld. That shiny weld is actually your weld, and the black material or the dark material that you crack open and removed was your slag. So basically, if your electrode has coating, the coating will neutralize all these impurities or oxides, and it will allow it to float on the surface of your weld. It will eventually harden, and it will be called a slag, S-L-A-G, slag. So at the end of the day, upon the welding process completion, you're going to take the hammer and you break open, or you break open that slag, remove that slag, and now you have your actual weld, which is the perfect weld that you've been looking for, right? So what are the functions of coating? Like I mentioned to you earlier, coating has got many functions here. It provides a protecting atmosphere, meaning that it protects your weld area from oxidation. It helps to stabilize the arc. So sometimes when you're welding, you find splatters, the weld will splatter. So it can be dangerous. So by using a coated electrode, it will reduce the splatter of weld. Okay. Number 3, it acts as an alloying element. What is an alloy? Alloy is a mixture of 2 or more materials to form a more useful material. So in this case, the alloy is actually going to strengthen your weld. Number 4, it increases the deposition efficiency. When you weld, your material will deposit in a more dense manner. So when it's more dense, you'll get a stronger weld. Okay, it gives you a good shape of bead, and it also slows down the cooling rate of the weld. So when your weld is when it is cooling down, you want your weld to cool down in a gradual manner, not in a sudden a drastic manner. So if your weld cools down in a drastic manner, meaning that upon welding, you take your weld and you try to dip it into ice, what is going to happen? Your weld will crack. Okay, thermal shock. So you may want to allow your weld to cool down gradually. Okay, and therefore you would get a very dense, strong weld. Okay, so like I mentioned to you, your coating composition, you have inorganic substances, organic substances, but the basic function again is to provide all this, this 1 to 11. So for exam purposes, make sure you know at least 3 to 4 coating functions. Okay, so back to our constituents of coating. The coating has several constituents. The coating, if it's going to form a slag, okay, if it's going to form a slag or it's going to remove impurities from the welding area, your coating will definitely have SiO2, silicon oxide, FeO, ferrum oxide, and MnO, manganese oxide. If your coating is going to act as a binding material, it's definitely going to have sodium silicate and asbestos. If your coating is going to behave like an deoxidizing constituent, meaning that if there's already oxides present in your in the base material, you need to deoxidize it. So you need graphite and aluminum as your coating constituent. Alloying material is to improve the weld strength. So you have vanadium, molybdenum, and tungsten as the coating material. So okay, back again to the first slide. If you remember, we were talking about the fundamentals of welding systems. So this is what I mean by using of fluxes. So you may want to use a coated electrode. It does not matter whether it's light coated or heavy coated. You may have to use a coated electrode in order to protect your weld area from impurities and oxidation. If you do not use a coated electrode, what is your next option? Option number 2 is to use other protective mechanisms, which we will see throughout this chapter later. Yeah. So number 2, welding speed. Okay, so when do you weld? The speed of welding should be considered because oxidation can take place rapidly. Okay, porosity is not desired after metal solidification, so you must make sure that you weld in a very fast manner. Okay, because you do not want oxides to get trapped, so you want to weld it quickly. And porosity is not desired after the metal solidification because porosity depends on weld shape. More porous is found in welding two parts with long narrow parting gap between them. Welding position. Flat welding is better than overhead welding. What is flat welding? Okay, so when you weld, the weld bead comes in the form of a crown. Okay, crown, if you remember. So the flatter the crown is, the better the welding, because when your weld has a crown, okay, you would consider it a bad weld because the crown has actually trapped air within the weld, and it is going to weaken the weld. Storage time before welding. So every time you weld your work, or you want to conduct a welding process, make sure your work pieces are cleaned thoroughly. Remove all the oxide layers on the surface. Remove all the impurities from the surface, and make sure your workpiece is clean. Surface clear of oxides. Okay, and the welding speed, like I mentioned to you, make sure you maintain a fast welding, because a fast welding of aluminum, for example, suppresses the formation of pores in the weld. So that's it for this lecture. Thank you very much. See you in the next lecture. I'll be posting assignment 3. Please look out for your assignment 3 and please complete it and hand it to me by next week. Thank you very much. See you in the next lecture.